Welcome to the pre-recorded lecture of 21st September 2020, and today we are going to discuss on correlation. Okay, and what correlation essentially means is essentially identifying the rock units which are distantly observed. Okay? So I'll explain what do I mean by that. The matching of rock layers with one location with the rocks formed at the same time in other location. That is essentially what correlation refers to. Okay? Matching of rock layers from one location with the rocks formed at the same time in another location. That is essentially correlation is all about. Now, let us look at this particular cartoon. What you can see that there are three offshore wells A, B, and C, and they go through different stratigraphies. Okay, so now you can see A essentially goes through 1, 2, 3, 4, 5, 6, and 7 rock layers. B goes through 1, 2, 3, 4, 5, 6, 7 rock layers. But C goes through 1, 2, 3, 4, 5, and 6 rock layers, right? Now, why that has happened? Simply because you can see that these number five horizon, this number five bed is essentially pinching out, right? It's not continuous all the way up to C. Now, when you have drilled this well, you don't know about this picture. What you are left with is simply three sections, right? So, section A, section B, and section C. Now, to the process by which you essentially say that this is horizon 2, perhaps. Okay, this is horizon 2, this is also horizon 2, and this is also horizon 2, and you kind of, and then this is horizon 3, 3, 3. Okay, this is 4, 4, 4. My apologies. 4. Okay, this is 5, 5, 6, 6, 6, and 7, 7, 7. The way you establish this particular picture from these three discrete uh, log panels is essentially called correlation. Okay, so we are going to learn what are the different techniques by which you can do this correlation. Okay, so the first technique is similar rock correlating similar rock characteristics. If you like jigsaw puzzle, correlation is the thing for you. Okay. So what is correlating similar rocks? So matching layers on the basis of similar color, mineral properties, or unique features. Now, if we look at this particular example, we can see two log columns, one A, of course, which is one A and another B, right? So we can see here that perhaps this there is one sandstone here, there is another sandstone here, so we can correlate that. Maybe there is a limestone here of the same color with the limestone at the top. So maybe these two are the same. There is another limestone here. We can correlate them. There is one gray shell here, we can correlate them. Now you can see here there is red siltstone. In column A, you have red siltstone and dolomite, which is not developed in column B, but you have the development of a limestone. So something, uh, uh, some sort of depositional environment that is being changed. Okay, and perhaps the column B doesn't reach all the way up to the granitic basement. So this is perhaps the basement up to which this column B is not going all the way up to. Okay, so this is how we can correlate with a very simple example by looking at the similar rocks. Now let's look at the next example. Okay, so suppose this is well 1 and this is well 2. Now here it is fairly difficult. Yeah, as you can see, there is a siltstone, limestone, sandstone. There are, so here is a one limestone. There are two limestones. How would you essentially correlate? Okay, and in these particular cases, what you should try to look for is index horizons. Now you can see here there is one particular index horizon which we called, which is the volcanic ash. When you find volcanic ash into log panels, they can be very easily correlated simply because the volcanic ashes are um catastrophic geological phenomena that happens for a very short period of time while a volcano is in place. Okay, and they happen very over a large uh, over a large area. So volcanic ashes are called index horizons and which can be very easily correlated. Okay, so you can correlate the volcanic ash. And now you can see that above volcanic ash, I have siltstone in well 1, and then so I can perhaps correlate siltstone with siltstone. And we can see here between ash and siltstone there is a limestone. So that limestone is not developed here. So perhaps there could be two possibilities, that there could be an unconformity in between. There could be an unconformity in between, or the limestone could have been, simply been pinched out. Okay. And then above siltstone there is a shell, which shell is missing on the top of well A. Now if we go beneath ash, what I will observe that beneath ash I have one limestone, so I can correlate this limestone to limestone. And then the sandstone, limestone and shell, they this well 2 has not penetrated deep enough to actually reach to sandstone, limestone and shell. Okay. So this is how we can correlate, right? So volcanic ash in large eruption as scatters over a wide area and then settle on the top of sediments, right? And ashes can be used as index horizons, volcanic ashes, and can be used very effectively as for correlation. Okay. The next thing that you can use for correlation is, meteorite asteroid deposits. So debris and ash that cover large period of the Earth's surface, like the layer of iridium from dinosaur extinction. Like you can see here, this is the KT boundary, Cretaceous Tertiary boundary, uh, is generally demarcated by this high iridium content rich layer, which is generally correlated with a meteoric shower. Then you can observe this layer here, this black layer. Okay, if you find this black layer, this iridium rich layer, which is thought to be formed by meteoric shower, these layers, they are also index horizons, which can be very easily correlated, used for correlation. Now there is another thing which we call as index fossil. Index fossils can be used for correlation as well. And index fossils are the fossils which lived over a wide geographical area, but only for a very short period in time. Okay. I will explain how it works. Remember, index fossils are the fossils which are spread over a wide geologic area, but for a very short period of time. So, for example, you can find here perhaps this trilobite. You can see here uh, the trilobite present in this shell in column 1 and also in column 2. So I can essentially correlate these based on the presence of this index fossil, which is trilobite in this particular case. Okay, so you will see that the trilobite essentially lived all over the world, but for a very short period of time. Hence, trilobite is thought to be an index fossil. So, of course, the short period of time we are talking about geologically, we are talking with respect to the geological time scale. Maybe something that lived for 100 million years, 100 million years. That is relatively short for us. Okay, 100 million years is relatively short for us. So we have to think when we talk about short period of time in the geological with respect to the geological time scale. Now you can see here three examples. You can see here three sections, and they are given as outcrop example, but they could very well be well one, well two, and well three. Okay, and you can see here this A horizon contains trilobite, which is a limestone. The K horizon contains trilobite, which is also a limestone, and the Q horizon, which is shell contains trilobite. So with respect to time, this is perhaps correlatable. Okay, A, K, and Q, they are perhaps correlatable simply because they contain this index fossil. Okay. Okay. Now let us examine these four columns. So let us say these are not outcrops; these are all wells. So this is well one, is well two, this is well three, this is well four. Now let us try to identify which one could be my index fossil in this particular example. And let us try to see this particular insect, okay, or this particular organism. So we can see it. So let us name these. We can see it in this bricky horizon. We can also see it in this dashed line horizon. We can see it here in this dotted horizon, in this dotted horizon, this dotted horizon, this horizon, here and here. So it is certainly widespread, but does it live with a short geological time? Perhaps not. So this is not a good index fossil. How about this one? This only occurs only once. So it is not widespread. Okay. This is not widespread, but this is certainly lived for a short geological time. But this then also will not be a good index fossil. Now, how about this one? Occurs here, 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 and here. Okay, so this is also widely spread, but you can see this did not live for a short period of time. Okay, now let us look at this spiral organism. Okay, you can see here this is traced here, traced here, traced here, traced here. Short period of time, widespread. So perhaps this is a good index fossil, and I can correlate this horizon. Okay. I hope the example was clear for you. Now let's try to see this particular example. Okay. How about, you will find out that this particular, if you do this exercise, you will find out this particular organism, okay, is actually matches the criteria of being widespread and also living for a shorter period of time. So based on that, I perhaps would be able to, you know, correlate these three horizons. So suppose I had a well here, well one, well two, and well three, okay, and they encountered these organisms, these different organisms that have been shown here, and doing some biostratigraphical exercises, I should be able to correlate them across the wells. Okay. Now let us look at this particular example. Okay, so find out, we need to establish correlation here. So one of the other index horizons that we can use for correlation is conglomerate. Okay, let us try to see where if we can find out conglomerate in all three of them. So you can see here, I can find conglomerate here, and I can find conglomerate here. So I will perhaps, you know, correlate this. Now you see that in this is well one, well two, well three. You can see in well 3, I don't have any younger stratigraphy over conglomerate. Okay. So in this particular, in well 3, a conglomerate is my youngest horizon. Now, if we compare well 1 with well 2, what I can see that I can perhaps correlate this shell, I can correlate this siltstone, I can correlate this red sandstone, I can correlate this fossiliferous limestone. But then this glacial deposit and sandstone is not present here. So whatever rocks we are looking at right now, this glacial deposit is perhaps my youngest rock. In all three columns, if we look, this glacial deposit is my youngest rock. Now, if we compare well 1 and well 3, we can perhaps see this black shell. Okay. So this black shell can be correlated with this. Limestone can be correlated with this. Okay. And this shell contains trilobite fossil, can be also correlated with this. And then we can see that this gray sandstone is not developed here. But then gray sandstone is certainly older than shell. So gray sandstone is the oldest of the rocks in this basin. So gray sandstone is the oldest rock in the basin, and the glacial deposit is the youngest rock in this whole basin. And that I have established by correlating uh, these horizons with, and our index horizon was conglomerate. Okay. Now let's try another one. Okay. So what we will try to do, we will first try to create a stratigraphic column from oldest to youngest in this particular case. Okay. Now let us try to see which particular bed is present in all these four locations. Okay, and you will observe that I have number 7 here, number 7 here, number 7 here, also number 7 here. So perhaps I can correlate number 7 in all four horizons. Okay, so let's do that. So we can correlate all number 7. And then what I can do, I can bring number 7, okay, at a same level. Okay. Although they are at different depth, but just for our convenience, we can bring them at the same level. And this bringing the same horizon in the same level is called flattening. So this is called flattening. This exercise that we just did is bringing the correlatable horizon on the same level, okay, forcing the what is that called, redistributing these columns in such a way that 7 becomes at the same level. That exercise is called flattening. Now we can see 7. So these rocks, of course, these rocks are older than 7, and these rocks are certainly younger than 7. So we can place 7 somewhere in between. Okay. So above 7, we can say that there is 1 in column B and column C. There is 1. So I can put 1 here. I can put 1 here. Okay. And then we can also see that 9 is written with 7 for these two columns. So perhaps 9 is contemporaneous with 7. So I can put 9 here. Okay. Now, above 1, what I have 4 and 6, okay, which is developed only in location B. So I can put 4 and 6. 6 is my youngest. Okay. Now, below 7, I have 2 in all 3. So I can correlate these two. So 2 is immediately older uh, than 7. Now here I see 2, 10, and 3. Okay. Here I see 2, 3 with an unconformity in between. Okay. So 10 was perhaps eroded between 2 and 3. Okay. So I can put 10, and then 10 was eroded here. And so there is an unconformity, and then 3. And here I can see between 10 and 5, yeah, there is 10 and 5, there is 3 here. 5 has not developed here. Okay, so then 5. Okay, and then also here you can see between 2 and 3, 10 is missing. And here between 10 and 5, 3 is missing, right? And then of course then 8. So thus we can rearrange our rocks from oldest to the youngest. Now let us look at a particular well log series, okay, and try to see how we can do a correlation. So you see these are different wells displayed in a 2D map. Okay, wells which are projected on a 2D map, and now we are trying to establish correlation between from between these wells. Okay, so I am arranging wells from here, 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 here. So these are wells which are like going down. Okay, and then I am displaying each of these wells. I'm displaying each of these wells. So this is A, B, C, D, E, F, G. So A, B, C, D, E, F, and G is perhaps here. The column is not shown. So I'm displaying the wells one after another. And the log that is generally used for such correlation is generally gamma ray log, because that has the information of the lithology. Yeah. So we can see here um, shell and sandstone. Okay, this is the gamma ray. This is the gamma ray log, right? This is the gamma ray log. So higher gamma ray corresponds to shell, and then lower gamma ray corresponds to sandstone. So you can see here broadly, here is my shell column. Here is my first shell column. Here is my first shell column. Here is my shell. Here is my shell. Here is my shell. Now, before the actual sandstone starts, you can, from looking at the log horizon, I mean, from looking at the log characteristics, I can see there is a small sand streak. Yeah, can I identify that everywhere? Yes, I perhaps can identify that everywhere. There's a small sand streak before, you know, the actual sandstone starts and before the shell actually ends. So perhaps I can correlate these. And let us name them as A. And then what can I do? You can also see here that with respect to the column, the next thing that we can do is essentially, so you can see here I have picked up this small sand streak before the actual sand come, and we have named it as horizon 1. Okay, and then what I have done, I have flattened it. Okay, I have flattened it. So you can see here I have flattened it over horizon 1. Although they are coming from different depths, but they are kind of leveled together. And then things become easier for us. Okay? I can see, then I can very quickly pick up the start of my actual reservoir, which is my horizon 2. This is where my reservoir starts. Okay? And you can see that perhaps this is where my reservoir ends. Okay, the first phase of the reservoir, maybe it ends here, maybe it ends here, ends here. So that will depend a little bit on my experience of working with sands with the reservoir, and then perhaps I can correlate these. I can perhaps find another sandstone unit here. Now perhaps this is the same sandstone unit. Don't know. Maybe it's missing here. Okay, that comes back again somewhere here with a shell in between, like that. This is how, but you got the philosophy. This is how we essentially correlate different well logs. Okay? But sometimes only gamma ray log uh, is not good enough. So with gamma ray, of course, we take the help from cores. We take the help of other logs, and of course we take the help of biostratigraphy, index fossils. Okay, by using them we can essentially correlate a log column. All right, so I will stop the video here, and I will take your questions and answer clarifications in the next live sessions. Thank you.